that right there is this
That's exactly
vehicle.
right.
No way. It's just split up in two right now. Man, there's a lot of movement happening around here, isn't there?
That's why I said it's a lot of coordination and matching of traffic and a lot of different processes to make this work and come together.
Oh wow, okay. This is a 10 out of 10 front.
That's a 10 out of 10 front.
Okay, that's a lot of space.
It's actually a mega power front.
Yep.
This video is brought to you by Iona, North America's premier charging network. With unmatched commitment to elevating the customer experience, Iona is opening America's roads to all EVs, giving drivers the coverage they need, the reliability they deserve, and the amenities they crave.
Hello, good morning, and welcome to another Out of Spec Reviews video. You join me in Dearborn, Michigan at the Ford F-150 Lightning Production Center at the Rouge EV plant behind me. I've already got my high-vis vest on, so safety third, as always. What we're going to do today is go on a tour of how F-150 Lightnings are produced and ultimately are really, made on their way to you guys. And I think it should be really fun. We've done a few behind the scenes factory tours on this channel over the last few weeks. You guys seem to be enjoying them. And Ford was cool enough to invite us out here to show how they make their awesome F-150 Lightning. If you're curious more about the truck, I've done tons of videos over the years on F-150 Lightning, so there is no lack of content from our side covering the truck, but in this video, it's all about how it's produced. So join me as we go on a full tour of the production process of the F-150 Lightning. Guys, I'd like to introduce you to my new friend, Rob. Rob, welcome to the channel.
Hi, my name's Rob Williams. I'm one of the team managers and team members here at the Rouge Electric Vehicle Center.
So you're going to be sort of our tour guide today.
Absolutely.
Which is so cool to have you as a tour guide, and you've been hugely instrumental in this factory. So tell everyone a little bit about maybe the history of this place and maybe even just the site that we're on.
Sure. So this is the Rouge site in Dearborn, Michigan. It's roughly 900 acres. Site was originally built in the early 1900s, right around 1914. Henry Ford had the idea of raw material comes in, finished product goes out. So the site has a very rich history. The building that is behind us is the Rouge Electric Vehicle Center. It is the newest assembly plant in our system. It was constructed starting March of 2020. In about 18 months, we were able to start building vehicles out of this plant.
That's insane speed.
Yes, this is the only plant right now building the F-150 Lightning.
Very cool. So my understanding is what we're going to see inside is specific to Lightnings, but just over there is where the combustion trucks are built.
Correct. Just right across from us is the F-150 combustion plant, and it shares the paint plant and the body shop. And the two vehicles are, the body and paint vehicles are put together and then separated for ice and lightning.
Okay, so we've got some sensitive stuff we're not going to film around here. You're going to tell us what we can and can't film.
Sure.
So Scott, you got to keep the camera on me, but I'm just going to point to the process more or less. So you have body in white on that side, in that building. That's where the structure of the vehicle comes together.
Yes.
It then gets transferred to another building, which is this way, which is where, it goes over here.
Is behind us.
Ah, okay.
That conveyor brings it over to final, and there's a similar conveyor that goes into this building for the BEV, battery electric.
So basically, the combustion and the electric trucks share the entire beginning process together.
Yes.
After paint, they split, and you're going to show us inside where we're going to start is right after where they split. The electric body and whites that are painted come down.
Yes.
And then that's where we're going to meet everyone inside.
Correct.
Okay, that should be really cool. What else are we going to do today? We're going to do like a water test at end of line.
Going to see some of our quality tests at the end of the line. You'll see just how we test the vehicle for water intrusion. We literally soak the vehicle for about 2.5 minutes, make sure there's no leaks.
That'll be really cool. And then I'd love to at least swing by and see how they're charged at end of line as well.
And take a look at how they're charged as well.
That'll be super cool. So thank you guys for joining us on the tour. Without your viewership, we wouldn't get to meet cool people like Rob and go on a tour of,
Pleasure.
you know, the factory he built himself from scratch.
Not quite. I had a little bit of help.
Yeah.
A little bit of help.
So can't wait to do this. And Rob, I'm gonna basically get the camera on you, and we're gonna go run through the factory. Can't wait to show everyone.
Awesome. Look forward to it.
Rob, we are in the factory now. What are we gonna see today?
This is the start of the assembly for the F-150 Light. This is the start of the final assembly process. The actual start of the overall process actually started across the street in the body shop. And what you're seeing come across are now the painted cabs and boxes. So that conveyor above us has all of the Lightning cabs and boxes coming over. They're coming down this elevator and being loaded onto an AGV where they will start in the trim process. So the assembly plant is divided into really 3 major sections: trim, chassis, then pre-delivery, and inspection. So the trim side is everything that the customer would see and touch inside the vehicle and all of the accessories. Chassis is really the powertrain and drive component, so everything the customer would feel. So we're starting at trim 1, where the vehicles are coming down and being loaded onto an AGV. This is called a VDL, vertical drop lifter. We like acronyms. They help make communication easier because everyone knows what a VDL is inside for.
So for the body and whites, are these built in the same sort of stamping and assembly as the combustion F-150?
They are built exactly in the same spot. They're very similar in dimension, so they're able to build it on the same line, and then they're diverted and routed to the right building.
And then where are the combustion F-150s built?
They're built in the main final assembly plant, which is a different building behind where we are right now.
Okay, so then the Lightnings get diverted after paint.
After paint?
And come down here and get plopped, sort of body and bed separate, so cab and bed separate.
Yes.
Onto different AGVs. So where do the beds actually come in? Because right now I'm only seeing the cabs here.
So they are all on the same conveyor. If you walk this way just a little bit.
Yeah.
And if you look up.
Oh yeah, here we go. Nice. So they come down sort of as a pod then?
Yes.
That's cool.
So to my left are the cabs, which trim 1. Then to my right are the boxes. They'll come out on those AGVs and get routed back to the boxes.
Got it. So that's pretty cool. So you got them rolling down either side there.
Yes.
Cool. Thanks for showing us.
So we're going to start on the cab side, which is trim 1.
And all these AGVs are station charged. Where do you even charge these things?
So they actually charge in station as they're going from step to step in the process.
Oh, very cool.
They have a charge shoe that extends down. It's a charging plate, and it's a DC charger in every workstation.
Wow, that's really cool actually. So they're always getting topped up, and you can see they have a little bit of LiDAR on them and sensors. And
so they do have sensors that allow them to stop. The lights indicate what status they're in. You can see the AGVs are also smart in that they know based on where they are, what station, they can raise, lower. The AGVs, some can turn 90 degrees, some can crab walk, meaning go side to side.
And this thing just got loaded right there onto that AGV.
Correct.
So what's really cool, and we were talking about this a bit earlier, is that the entire process has no conveyor belts until we get to the end.
That's the only conveyor.
Yeah, that's wild. And so you basically got every single Lightning going on its own AGV for the entire production process.
Correct.
That's so unusual. It's really cool. Actually, I think the only time I've ever seen something like that was at a factory in China recently, and you guys were doing it before them.
Yes. So yeah, these AGVs are actually smart. They carry all of the data for that vehicle, which is why they're on an individual AGV. So we know exactly where they are in our system.
Okay, very cool. So I'm noticing, are these protection pads that get loaded on?
So yep, these will go on the front fender. Again, high touch surfaces where the operators have to lean and do other things to complete the assembly process. So we put on a cover. So the operator is actually going to grab the cover and put it on the vehicle. You'll notice the AGV adjusts height. Reason it does that is we took in mind the ergonomics for the operators, so we make the workstation fit the right height of the operator.
That's really cool. Great to see.
So we're walking through trim. This is the start of the build. That is literally an empty cab. It has literally, here, walk this way.
Yeah.
Just watch your step.
Yep.
And take a look inside. It is a completely empty cab.
Yep, just painted body in white, basically.
Okay, that's literally painted body in white.
Very cool. And so you have some sound deadening material, some vents for it to go, and man, these things go pretty close, but they know exactly where we are, right?
They do.
Yeah, that's awesome.
They thought we were in the way, they would actually stop.
Okay, very cool.
Yeah, as we go through the assembly process, they will get built up to what you see as a finished vehicle. Trim 1 is the start of the trim process. Like I said, it's an empty body and painted body only. And
then they start loading stuff in there.
Correct.
Wow, very cool. So you've got wiring harnesses coming down over here, some looks like sound deadening material going in.
Yes.
This station.
Sound deadening, carpet, a lot of the, like I said, everything you will see inside the vehicle. Trim panels inside the hood.
And how dissimilar is this from the combustion factory, would you say?
So they are very, very similar in design. Our process architecture, meaning the steps that we take to put it together, also very similar.
Okay.
The biggest difference is speed at which they're going. Because the combustion has a bigger overall market volume,
Yeah, you're pounding those things out.
those have to go much faster. Here, a little bit slower, but it's the same number of steps in total, just done by fewer people because it's at a slower pace.
Got it, makes sense.
We also build in the order that our customer orders, which is why you see the multiple colors, not building in batches. So the operators all have a very good idea of what they're building based on the part of the screen that shows what we call a broadcast number. They reference that number to the model of the vehicle that we're building.
Okay, very cool. So I've noticed we've come to the end of that straight line, I guess.
So this is the end of trim 1.
Okay.
So now it's going to make a loop and go through trim 2. And it'll continue that serpentine type loop until we get to the very end of trim, at which point it'll cross over into chassis.
Okay. And the chassis are built up separately from the cabs.
So just like you saw the body in white, the process of chassis starts with an empty frame, and we build the frame up with all of the drive components, the e-transmissions or PDU and SDU, primary drive unit, secondary drive unit, and the battery. Then we'll deck cab and box onto that frame, and it'll start looking more like a truck.
Very cool, very cool. And there's some marriage process, I assume, to bolt them all
We
together?
can actually take a look at that.
Cool.
This is a sub-assembly. They're building up the wheel ends with the wheel hubs, brake assemblies, and then they'll re-rack these, and then they'll get reintroduced into the assembly process where they'll be put on as an assembled component. That was the end of trim 1. Start of trim 2. Like I said, it goes in a serpentine manner up and down for best utilization of space. What we're walking towards is part of the chassis process just before marriage. So you'll get a very good look at the chassis of the vehicle with the battery as it's assembled just before we deck the cab and box.
So I can see over here they're putting the motors in.
Yep.
That's sweet.
So those are all of the primary and secondary drive units, or the e-motors, e-transmissions. Walk this way.
Now we're starting to see the stuff we love to see.
This is the complete chassis.
And this is basically, so they zigzag their way up there and come
Correct.
out on this end. That's pretty sick.
What they're doing is a final inspection of all the wiring, all of the electrical connectors, all of the fluid connectors for the coolant system. Make sure all of those are done. The 2 collaborative robots, or cobots for short, have cameras on the end of them that will literally take pictures of all of those connectors, display them on the screen for the operators. They will verify that yes, that connection was correct, and then denote it, and it'll move on to the next part of the process.
What's interesting is you're already putting the lower front bumper cover on here. So this is already designed to go on a specific vehicle. It's not like you're building up a bank of chassis and motors.
No, we are building, again, in order of broadcast, meaning what our customers are ordering, that's the order we're building. And you will see, so that's a white bumper. When this comes across the aisle, you'll notice third truck is a white truck, so match that chassis.
Oh, so that right there is this
That's exactly
vehicle.
right.
No way. It's just split up in two right now.
Correct.
That's pretty cool. Okay, so this one's going on, I guess, that next truck.
You got it.
This one here. And this is on its way to its new home.
Yes, we're on purpose going to stop this a little bit to get you a closer look.
Yeah.
So this AGV is one of our largest AGVs. This one can also walk, crab walk, go side to side. I'm going to on purpose stand in front of it. It's going to get really close to me, beep, and tell me get out of the way.
Yeah, so that works.
It does work. This gives you an idea of just how large this vehicle is. This battery, this is the battery, weighs 1,600 pounds. Every one of these orange cables is a high voltage cable that connects to the traction battery. This is the main connector. This is the power inverter. This is the primary drive unit. So front and rear have its own drive motor, which is why the vehicle can generate so much torque. Huge suspension, just as capable of four-wheel capability as the combustion version. Frame is a full depth frame, protects the battery, and again, just as much capability as the internal combustion version for the battery.
And this is an extended range battery. Is there any way to know?
There is, form factor wise, they look exactly the same. I'd actually have to look at the label to tell you whether it's an extended range or not.
Yep.
I can't see it the way it's assembled now.
Okay, so the label's up underneath there then. Yeah, okay.
So it does still have a 12-volt battery. But that's for all the accessories for your doors, windows, and other things when the traction battery isn't engaged.
Right.
So this is gonna literally walk across the aisle,
Okay.
pivot like that one,
Yeah, you can see that thing doing a twirl over there.
and then they're gonna lower the cabin box onto that frame.
Well, we got to watch that. We've been following this one. We got to see it go into this white F-150 for sure.
Walk across the aisle.
Yeah,
Back too close
cool.
to it again.
Yeah, we're freaking it out.
Yeah.
Sorry,
These
little
are very,
ATV.
very safe. The scanners provide a 360-degree safety net around it, so if it does approach anything or get close, it knows to stop.
Yeah, that dude. We're just sending it through here. This is great. We got another one coming this way. I'm guessing it's gonna go that way. So, all right. So
The battery based off the trim of the chassis coming.
that's what I was thinking too. If we
Yeah.
could see the chassis or the body that's coming this way.
Just, yep.
Looks like it looks.
Watch your heads. So,
It
yeah.
looks to be a flash.
Yeah, it looks like a flash, is what Tom's saying.
Yeah, I believe that is.
Okay.
We have
Extended range, right?
23.
Yeah. This is the new battery, right, Tom?
Yep, my truck has 123 usable.
Yeah. So it's a little bit less capacity but higher payload.
Yep,
Okay.
exactly.
So we got to do some more testing on your truck with that new battery.
I can't wait.
All right. So this thing, they're about to get put together. Yeah.
So literally,
Could be a Lariat.
painted
Ah,
mirrors.
painted mirrors.
Lariat. I know too much about these trucks.
Yeah.
They're going to deck the cabin box onto the chassis. Call it body deck, or we call it body deck. It's where we're decking the cabin box. Marriage cell, which is a little bit different, is where we marry the cabin box together after they go through the full assembly process.
Cool. So
They've
here
already
comes
been
our
married.
white Lariat. Probably extended range, we would guess.
Yep. Seco.
Yeah, coming to look. So here's that white truck that perfectly matched up timing here with this chassis. And this thing's gonna basically do a tank turn, bust a UE, and get up in there with that truck. How sick is this? Now, if only the F-150 Lightning could actually do this without the help of an AGV, that'd be pretty fun. Ford, maybe add a new feature. Tank turns. Tom, how cool would it have been to have your own truck here and you could have watched it get built?
That would have been wild. I kind of want to buy one again just for that.
Yeah. Man, so now they're getting all matched up, and just like we saw with this Lightning Pro, I'm guessing this one, right? This black one?
Could be Pro or XLT.
Yeah.
Bumper, so
Yeah, XLT. Yeah.
XLT or flat.
Yeah. So just like we saw with that one, this is going to basically go and get decked up to the cab. That's awesome. Cool. So what happens as we go down this line now that they become one truck?
Now we'll finish the rest of the assembly process where we're making all of the connections for the instrument panel and other stuff interior for the electrical system. Traction battery is installed. It's coming to us at about 60% charged. So we are actually completing all of the other connections to get the vehicle ready for being a finished vehicle.
Yeah, that's actually what we went out. We went outside to see what state of charge they were at, and they're 60%. And 60 is pretty good. That's plenty to move around as far as you need to go.
Yes. So to my left is one of the earlier chassis lines. This is chassis 2.
Okay.
Chassis 2 is everything being built up on the chassis all the way up through the final traction battery and all the connections. Chassis 3, which is to my right, it's more of a finished vehicle with the cabin box already being decked. Every workstation has what we call an airproofing station. It is literally a digital system that we check and verify every fastener, every secure. Every one of the components goes on the vehicle to verify that it is the right component and put in at the right spec, at the right torque. So we have 100% traceability for all of our quality. We also look at no fault forward. So anything we can repair in station, we'll repair and make that correct. That's why we have so many checks. That's why each station has its own quality check. We'll wait for this IO.
Now, Rob, you're mentioning, of course, on the fault side and, of course, going back and making sure problems don't make it to end of line. Lightning's been in production for a few years now.
Yes.
So I'm sure a lot of the real obvious items have been solved by now. But early on, were there things you were finding in the field and you're like, hey, we can adjust this back in the factory?
Just like anything that's new, yeah, there were things we didn't know when we designed it, and a lot of those lessons learned were read back across into our process as well as read across to the rest of our vehicle fleet. So we took all of those lessons learned and actually learned from them so we don't repeat it going forward.
Yeah, I'd love to hear it. That's the most important thing. Like, I'm always an early adopter. When something comes out, I know, probably going to have some bugs, but as long as you guys, and Ford's been great about taking owner feedback and really, I would say, adjusting and improving, not only from a software side, but hardware as well. Very, very impressive from my side how receptive to feedback your company is.
Yes, we very much are customer focused. Even our operators, we built our processes around the operators. So we took their feedback on what makes a great assembly process and integrated into it. And we carry that same philosophy all the way to our finished customer. What feedback do you have for the vehicle? We want to hear what that is so we can make the next best vehicle that's on the road for tomorrow.
Love to hear it.
So we are ending the other part of chassis. This is still the other part of chassis 3.
I should pay attention to where I'm going. I just bumped into Rob. Sorry, dude.
We're going to cross over to where we actually deck the battery into the frame.
Oh, nice.
That's going to be chassis 1.
Okay.
And we'll point out a couple key things as we go through our process as we walk out.
Now, of course, you're doing final assembly of the vehicle inside this plant, but
Correct.
Are there also sub-items that are built here? Like, for example, I saw someone actually making the whole dashboard here as well.
So the dashboard comes to us as a sub-assembly, and we complete it in-house. Then that gets routed and integrated back into the main line. The reason we do the sub-assemblies, it makes our assembly process much more efficient. So this is chassis 2. This is the longest chassis line we have. There's just over 25 stations, but this is where they're doing the majority of the chassis and build up with the charger and all of the other infrastructure to drive the powertrain of an electric vehicle. To my left is chassis 1, and this is basically the buildup of the frame. What you'll notice is it's upside down. The large suspension components, even though they're light, they're still very heavy. The reason we do it upside down, gravity works in our favor upside down. Allows
Good
us-
point. That's great.
Allows us to be very smart in how we assemble the vehicles. So what we're walking past is caster camber, where we're setting position of the spring and initial suspension. We'll continue to walk through and you'll literally see the chassis get built up to what looks like a finished chassis, then very similar to what you
Comes
see
on
over
this side.
here. On
So are
chassis.
these the wheels and tires for what exactly? These are the final wheel and tire package?
So these are not the final wheel and tire. So believe it or not, every vehicle has 5 wheels. These are the spares.
Oh, that's right. You put a spare tire on. That's great. So many trucks don't come with them.
No, we deck the spare tire right now. Much easier to deck without the cabin box being there. They get it loaded and secured in the final position. Notice the frame is still upside down.
Yeah.
Again, ergonomics for our operators and our team here. Stuff they're putting on is all underneath the vehicle. So by presenting it upside down gives them a much better time to install and better ergonomics for their process, their end of it.
You know, I can't think, I've been to many EV factories. Off the top of my head, I can't think I've seen much done upside down like that. That's pretty smart.
And like I said, we very took all of the input from our operators and we wanted to make the process fit them. When they are actually able to do something better in a safer, more ergonomic way, we get a better product. So what we're coming up to behind me and on my left is what we call frame flip. Now you take 2 very large robots, grab the frame and roll it over.
Oh, cool.
The battery by itself weighs 1,600 pounds. The frame, with it being partially assembled, weighs another close to 1,000 pounds. So these are very large robots that have a payload capacity of just over 1,300 kilograms. Doing the math, that is 2,800 pounds. These are very unique robots, and they are synced to roll the entire frame over at the exact same time with the same motion.
Right, so you grab them each from each end then?
We're gonna grab it from the end, and it's gonna roll it over. So you'll notice 2 types of AGVs. We call these the chassis AGVs, and then that small AGV has the battery.
Oh.
It's gonna route into the cell. The robot will pick up the battery, so the center robot, get it in a ready position. The 2 other robots on this end pick up the frame, lift it, roll it over. Then they'll deck the battery onto the AGV and then lower the frame right side up. Then once it exits the station, they'll actually secure the battery.
Very cool. So this is where battery goes in chassis then?
Correct.
Okay, neat. So all the battery enclosures, you were saying they look pretty identical between the different batteries on offer, right?
They do. They are exactly identical. So from a standpoint of form factor, they have to go into the same frame, same chassis, so they look exactly identical. Gonna get out of your way so you can see that.
Yeah, let's take a look at this. This will be pretty cool. Man, we got some big ass robots moving. That's awesome.
So like I said, they have a payload of about 1,350 kilograms. That's just shy of 2,900 pounds apiece.
So this one on the right's got the battery at the moment.
Correct. These 2 are gonna position themselves to pick up the frame. They'll use a vision system to help guide it and finish the positioning. Then once they clamp and have the frame securely, they're gonna pick it up and roll it over.
No, it picks it up like nothing. That's wild.
Exactly.
Dang, what the heck?
So now they'll deck the battery back to the AGV, then they'll lower the frame into the normal position, so the upright position. Then once it exits this station, it'll go into a station where they'll actually put in the final fasteners for the battery to frame. So it secures on 4 spots each side of the frame.
Very cool. There we go. That's awesome. Man, that is such a cool process. Wow, that was cool, Rob. That's awesome, dude. Are you bored of seeing this every day?
Actually, no. It's one of the coolest processes we have. So yeah, it's amazing how integrated this is, just how complicated it is.
Yeah, and it's happening, you know, of course, like many modern production processes, but there's no one here monitoring this. It's all automated.
Completely automated, yeah, all robotic.
Yeah, and that's like a pretty complicated process to not at least have someone monitoring. It just does it. That's amazing.
Yes, it's the right frame to the right battery every time, and that varies with the rest of the process. So where the frame and everything matches the chassis as it goes through the rest of the process.
Super cool. Thanks for showing us that. That was amazing.
So we're gonna kind of walk back past chassis 2. So at the beginning, once it exits, it's gonna go to these stations where they're gonna complete the secures to the battery, continue the assembly process. Now right side up, so all of the components they're putting on now, the vehicle needs to be right side up. Again, better presentation for the operators so they have better ergonomics and access to the things they have to assemble.
Yep, sounds good. Very cool.
We're headed towards the end of the line just before the vehicle is ready to drive off. So we're going to see tire install, and believe it or not, even though it's an EV, there's still 4 fluids that go in an EV. So there's a coolant system for a closed loop coolant system that works through the battery, windshield washer fluid, of course, brake fluid, and then AC refrigerant for the AC system. So all of those get put into the vehicle just before we drive off. And then after the fluid fill, we put on the finished production wheels, and it drives through the rest of the testing process.
Okay, so it never drives on another set of wheels, right? The production wheels, those are the first set it goes on.
That's the first set it goes on.
Okay, got it. And do you have a supplier park nearby to do just-in-time delivery?
So it's pretty unique. The way our plants are structured, we have what's called a virtual warehouse. So our material handling folks keep track of all of the parts that go on the vehicle and the bill of material, and they marshal that in just in time. To make the plant large enough to house that much material so we can build every iteration of our product, we'd have to have a plant probably 5 times as large as this.
Right, wow, yeah.
So MPNL has a very tough job with logistics, tracking and getting those parts in. Yes, there are several local warehouses that keep that part separation and coordination flowing to us based on our production schedule.
It's really cool to see all of this get built up. You know, of course, driving the vehicle, it's always just a finished product that you go to the dealer, but this really, I think, paints the picture to how much work and effort goes into building one of these things. It's not easy.
No, there is a lot of integration. Right parts at the right time to the right point on the line. There's a lot of coordination that goes into it.
You know, and Ford pretty much invented the production process, so you guys are the OGs in this space. But, you know, from your impression, when Lightning came to be, I would imagine it must have been easier to build this truck than a traditional startup automaker, perhaps, because you have so much manufacturing expertise built into the company.
Yes, we definitely leveraged that when we built this plant and took a lot of that in consideration. One of the successes for the launch for this plant was all of that initial collaboration and the lessons learned from previous plants that allowed us to hit the ground running, so to speak, with this product. Previous launches, we did some of that. This, we did so much more to ensure that the success. And all of those lessons and that collaboration now going into our future products.
Very cool. So yeah, you can see it all zigzags down, but then this is really where, like we saw earlier, comes close to the end.
This is one more line over. It will be literally where the vehicle is ready to drive off.
Oh yeah, so that one just fired up for the first time then, I guess.
Correct.
Oh, that's cool.
Correct.
So do they come preloaded with software, or do you have to install that on the line somewhere?
Some of the modules are preloaded with software. Other ones we do over-the-air updates.
Oh.
Our vehicles and our product line have got very, very smart. They are as smart as most of your cell phones. This vehicle actually has an onboard modem. The infotainment system literally has nearly the same capability as your cell phone.
So this is the first time this truck's getting dropped down, right?
This is, yes. That conveyance is called an EMS, or electrified monorail system. And that carrier houses the vehicle on the frame so they can put the wheels on. And then once the wheels are on, it'll get lowered. Those clamps will open up. Driver will enter the vehicle and then drive it through the rest of the process.
Dang, that's pretty cool. So yeah, definitely can't wait to see what it's like when someone gets in this thing and fires it up. So that's it, holding up its own weight, really for the first time ever.
That is correct, yeah. So the carrier
really
will
cool.
get out of the way, and the driver will enter the vehicle.
And is it the same driver every time, and they just got to go find a parking spot, or how does that work?
So there's multiple drivers.
Yeah.
So part of the process from here is now calibration and testing of all of the cameras, some of the other electronics on the vehicle. So this is what they're going to go. You're going to step. Okay, hit me.
Yeah.
They're going to go through that process from here forward. A lot of testing, and we'll walk by that once they do that. So they're going in, verifying again, inspect all the way through the process. Then they will drive off and go down the rest of our process.
Cool. Well, let's. Which way do you want to head from here?
We're gonna kind of detour really quick.
Okay. Cool.
So that's the very end. What you're gonna see here is where they're installing the tires.
Oh, okay. Nice.
So this is literally tire install, and we actually use a very complicated spindle to secure all the lug nuts at once.
Oh yeah. Very cool. And that's to make sure they're all torqued properly then?
Yep. So there is an electronic system that is measuring that torque. So they know, literally to the exact Newton meter, how much torque is required. Like I said, he engages the tool, walks away, tool retracts.
Very cool.
Those are tire monitor systems. They turn on the tire pressure monitors, verify they're working accurately, and then it continues down the process.
Oh, interesting. So this is a TPMS sensor then?
Correct.
System. That's I've never
Black,
seen that.
flat boxes, they're just antennas that wake up the sensor, turn it on, and verify.
Oh, cool. That's awesome. Super cool. All right, Rob. So we just saw this Lightning that just finished up, got pulled away. Unfortunately, off camera. Would have been cool to show the first start and drive, but we got the other truck that went through earlier.
Okay.
And yeah, so does every truck go to the same spot afterwards, or where do they bring it?
Every truck goes to the same spot. So this is, believe it or not, still part of the process. So one of the things we have to do is, like I said, take them all through calibration and testing. The headlights have to actually get aimed. So we call it headlight aim wheel alignment, WAHA. What that is we're aligning the wheels and the headlamps to the right setting so that everything's straight. That is now an FMVVS standard for the headlights to be aimed correctly. So we actually take that through a process, and it is all digitally logged and checked.
Can we check that out really quick? I'm sure we can't get too close to the sensors, but it would be cool to see it.
We're going to get pretty close.
Okay.
You're right. We can't get all the way close, but we're going to get really, really close.
Awesome. Nice. And that's what these 3 bays that you have over here?
Exactly. So what you'll see is, kind of come over here. What happens in this spot is the vehicle goes over that pit. There are operators underneath that are doing the final alignment and setting that alignment.
And are these bumps just to seat all the suspension?
So those bumps are another check. Not to seat all the suspension, but if there were any bonus parts, a bolt or something loose, that's to go over it and make sure that, yeah, there's nothing there and something we could check before. Once they just kind of let this person through.
Yep, so this one's going for another recheck then.
Correct. So, underneath there are operators that are setting the final wheel alignment, and in the booth ahead, it's blacked out. There is a wall that comes down, and that's how they align the headlamps. There's a sensor that measures distance and ensures alignment. All of these are electronic and digital sensors where we're doing and logging all of those checks electronically.
Yeah, it seems like a really nicely utilized piece of space in this building too. You have, your lines right there, everything kind of zigzags up and back. It's pretty nice.
It's it. Like I said, a lot of effort went into the design. We wanted to make sure that we had the best utilization of space and optimized it for our processes.
So what's happening over here right at the end of this station?
This is another part where it is a lot of the onboard systems, the 360 cameras, the park assist cameras, all of those are being calibrated, turned on, and verified that they are working correctly.
Very cool.
So you can't actually see it because there's vehicles parked underneath. They're plugged into the OBD2 sensor to get the electronic feedback. There is a black and white targeted floor helps calibrate the cameras, and that's what they're sitting on.
Oh, very cool. And so each one of them gets parked sort of in this, is this kind of like a staging area, or what's happening
This is a
here?
staging area. You'll notice those devices. Those are some other devices that, again, check some of the electronics. Because of the high amount of electronic content, there are a lot of checks we still have to go through before we get into the end of the line. But they get staged here once they're done being checked, and then driven to the very end of the process where they will do their final check.
Got it.
We use mobile automated vision inspection systems to verify if there is a quality problem that does suddenly crop up, and we want to have a visual inspection for that. We'll deploy these devices and take a look at them. We'll do other inspections in this area to ensure quality all the way throughout our process. Box and cab together. So the AGVs merged into a single point. This system takes the cab up, advances, and then the next station will pick up the box on the other carrier behind it.
Got it.
Now, they're a matched pair, and then they go through the rest of the process where they're decked to the chassis as a matched pair.
Cool. So this is the bed for that truck right there.
Correct.
Man, there's a lot of movement happening around here, isn't there?
That's why I said it's a lot of coordination and batching of traffic and a lot of different processes to make this work and come together. Okay, so we do other checks based off of number built. Some of the stuff we will do is we'll come back and audit a vehicle. So some of the vehicles you saw coming back were as a result of an audit. Because of that, we also put in a level 4 charger in the building. So that large block is a level 4 charger. Again, 480 volts, 230 amps. We'll charge the vehicle from anywhere from, take it from 2% all the way to 80% in just under 30 minutes. You'll notice the size of the cables. They look very much like what you would see for a gas station. Those are electric.
Oh yeah, our viewers know all about these things. Yeah, they are charging enthusiasts. So yeah, it looks like we got some BTC chargers there, and awesome to see it. That's great. And so what are you using that one for?
So that's some of the audit vehicles. That's where if we want to do an audit or a recheck, we have the charger there. So if we had, for example, a software issue where the handshake between the charger and the software on the vehicle were an issue, we could test it there.
Oh, very cool. Good to see. And then all of these individual workstations, what are they used for down this line?
All of these workstations are test and audit stations. So we actually activate the onboard modem, sync, and the infotainment system. We turn all of those on and validate that they are working as intended.
Very cool. And does every truck have to go to one of these stations then?
So we do it based on an audit basis. A lot of the electronic checks you saw earlier,
that kicks them on?
Validates it and confirms it. This is just a double check to ensure that we have it right.
I see.
One of the other weird things we have to do, you'll see it a little bit further down, is we actually have to weigh a percentage of our vehicles.
Oh, really?
It's a federal standard.
Okay.
So we've integrated a process where we can pull the vehicle offline, weigh a percentage, and confirm the weight.
Okay, interesting. That's good. Good to know. Never heard of that. That's
It was a weird standard that was dictated to us. So.
And so why are they some forwards and some backwards?
So again, our process, we took into account what works the best for the operator. So if it's coming backwards, it's because the work they're doing is on the rear side of the cab. And it makes it much easier to do with the AGVs. The AGVs give us the flexibility to orient the part to the best position of our operators.
So are they going to do a 180-degree turn here?
They actually do, that station.
Oh, wow. Cool.
So the AGVs have the ability to literally pivot 180 degrees.
Yeah, it's so funny to go down a production line and see completely different orientations right there. That's wild. And so that's really a benefit of AGV. You couldn't do that with traditional conveyance.
We could not do that at all with traditional conveyance. Not very efficiently. So the cell we're approaching on my right is where we automatically deck the front and rear windshields.
Ooh.
So this is actually all robotic. Operators will prep the glass, and then the sealer is applied via a robot, and the glass is decked via a robot. Robots use a vision system to set the finished position. Plant's pretty bright, except over this work cell. We on purpose turned off the LED lights to allow the vision system on the robot to work.
Oh, wow.
bright lights, and the glass would actually present kind of a problem, and it makes the vision system on the robot a little, takes it out of sync.
So all the vehicles on the right, are these part of the audit vehicles as well?
These are either part of the audit vehicles or vehicles that are on their way to the finished part of the process. We had to take up space for the AGVs to return from the box line, so we had to reorient the vehicles a bit.
I see.
So step this way. So that's the box line. It's the smallest of our trim departments. It's only 13 stations. Not a heck of a lot goes onto a box, but still needs to be assembled. This vehicle is going to go into the glass deck, and you can see that robot is going to deck the back glass. You'll hear a very strange noise. It's suction cups holding that glass. You'll hear them release once it's set.
Ha, that's wild.
Yeah. So the front glass is next, and it's the same process. On the end of that robot, the end of arm tooling has a series of cameras and everything else that helps set the finished position. This is, again, another robot cell that's 100% robotic, no humans other than loading and prepping the glass. Then the AGV will advance.
And process continues.
The process continues.
Nice. Now, how many hours a day are you guys running this plant? Is it all day?
Just one shift. We aren't running all day.
Yeah, okay, cool. Yep. Nice. All right, good stuff.
All right, so we're gonna kind of continue through the rest of the process. This is the end of line. This is where we do all of our finish testing just before we get it ready for nearly the end of the process where we send it to a tracer.
So in the bed line that you have here, this is where you'll put in things like the Pro Power ports and stuff like that?
Pro Power ports, all of the other bed accessories and utility features, the clamps, the power port, the different tailgates, the step tailgate. The Lightning has a couple different tailgates based on trim level. One has an LED version for the higher end. The Pro version does not, but it also has other features where there is a work deck on the back of the tailgate where you could actually use it for your contractor to stage tooling. They're verifying the step.
Super cool. And then this is doubling back down to now final end of line.
Correct.
So the only part where they get driven, I guess, is to do the WAHA checks, any audits, and then they come right over here to this line.
Right over here to this. So they get driven onto this line. So we call it a two-strand, which is basically a belt conveyor in the floor. And they start the process. So the blue box behind me is the start of that process. This is what's called AVIS, Automatic Vision Inspection System. So every one of those gray boxes and red wires is a camera. Those cameras are taking a static picture of the vehicle, and what it's verifying is not looking at fit and finish, but it's looking at colors, making sure we have the right wheels, the right bumper caps, the right mirror caps, all of those things. It's also taking a picture of the vehicle in the condition that we built it. So in
Rob,
the
can we stand over there? Is it possible to show what it looks like in there? Or maybe on the back side?
Sure.
Yeah.
Just have to be very careful.
All right, we'll be careful. We're going in deep here, folks.
Just watch your head.
Yep.
So the other thing they're doing is they're verifying some of the stuff on the underside. There's a skid plate that goes on underneath. We couldn't put that on earlier in the process because that's how we're setting the wheels and doing that portion of it. So operator drives on, and then we'll exit the vehicle once the conveyor starts. Yeah, you can see inside of that booth all of those cameras. So in the event something happens between our finish process and it making to the dealer, we actually have a finished picture of the vehicle, how it left.
That's pretty cool. And this is, I guess, there is a stage somewhere where you'll send a photo to a customer along the way?
So this was where we were doing that, yeah.
Oh, cool. That's not happening anymore, is it?
We only did it, I think, the first year we built.
Oh, okay, it was really cool.
It was very cool.
Yeah, but this is where the photos were taken
This
then.
is where the photo was taken.
Oh, that's neat. That's really cool.
So this is where we've married technology and people. The vision inspection and taking that picture, much easier accomplished with an automated system as opposed to a person. But as you can see, as we go through this part of the process, There are stations that are automated and stations that are manned. Humans can still detect some things that cameras cannot. That's where we've combined the two, where we're using new technology and AI, as well as people to make the best product we can going forward.
And so what's happening over here? I'm seeing
So that is the underbody skid plate. That is the very last part that goes on the vehicle.
Ah, so that's what's going on into
Yep.
there?
Step
Very
up
cool.
this way, you can actually see I'm making the final secures. So there is a person in that pit securing it with a calibrated gun and verifying the torque as they put that plate on.
Very cool. And then this process here?
So this is what's called EINS. This is another AI process. This is where we're measuring fit and finish on the vehicle. So we're using a vision system to actually measure gap between door panels, between cab to box, fender to hood, fender to door.
And that's all vision based.
It's all vision based. If you look inside that booth,
Yeah.
there is a halo of cameras. The lights just went out.
Yeah.
There's a halo of cameras that are taking a picture of the vehicle, and then they're going to display it on these monitors. That display provides information for the operators to make adjustments.
Oh yeah, I can see adjusting a door right there. How about that?
Exactly.
Very cool.
All of this matches what our customers' expectations are. So they are looking for a very specific fit finish. So we've actually calibrated it so that it is a actual measurable value. And it's not just by.
Yeah, my colleague Colton is obsessed with build quality, and so he always checks this stuff. So that's his best friend right there.
We literally take a picture of every one of the components.
Yep.
And then go from there.
Very cool. Love to see that. And do you do anything differently for higher trim vehicles versus lower trim, or it's all the same?
All the same. Every vehicle we treat as if it's the highest trim quality and the highest quality vehicle.
Very cool. And this is sort of final paint checks then?
Final paint check. So it's good that we're seeing a white vehicle. One of the most difficult things to inspect is for a defect on a white vehicle because it's so reflective. Cameras aren't quite there yet. Getting there, that's why we still have people. So one of the things you'll notice, they'll actually touch the vehicle to feel for a dent or a defect. So that's part of the process. So they're both doing visual as well as touch. Some of the character lines and other places, especially on a white vehicle, are very hard to see.
Totally. That's really cool to see. And now, Rob, we're actually going to go back in time in the next clip.
Correct.
Because earlier today, you and I rode through this water ingress test. It was super cool. So let's roll that clip now, because this is what happens to check for leakage right at end of line.
Correct. So this part of the line is called the CAL line, customer acceptance line. All of the stuff on the vehicle, we function test it, verify it before we send it to the second to last phase is before we ship it to a customer. So what we're going to take a look at here is going through a water test. Literally, it's a 2.5 minute test where we put the vehicle through a deluge of water and verify that it's not leaking.
And is that right in this metal box here?
That metal box behind us.
Cool.
360 degrees around the vehicle, so including underneath, we validate that the vehicle does not have any leaks whatsoever. And that's what we're testing. We'll come out of the other side, we'll take a look inside and make sure that it truly is leak-free.
And so you gotta get them wet, you gotta blast them, and then you gotta dry them as well.
We actually don't dry them because we're taking them out. So you can take a look. It's got windows so you can see through it.
Oh, cool.
You're going to get a view from the inside of the vehicle as it goes through the process.
And normally people don't ride through this, right?
No.
Okay, but we're going to be able to because you're awesome. Thank you so much.
Our plan to recirculate the water, so we're also energy conscious. Versus having a once-through system, we recycle the water, and we use about 80% less water than other processes that are similar to this. So this portion of the line is where people are visually inspecting for any surface defects, paint defects. Anything they detect, they will flag and will pull it up to the side to make the correction. And they're also looking, like I said, any blemishes, any surface defects, some things that only the human eye can see on a vehicle. That's why it's so bright and the different lights. We're gonna cut through this way.
And what are the type of defects that you find, or now that you've been building them for years, are the defect rate pretty low?
They are extremely low. Yes, they're extremely low. Some of the defects they're looking for are surface defects and things that that could happen during the assembly process. Something gets bumped, something gets scratched, something like that. That's what they're looking at there.
Yeah, doing the door thumb test over here. Love to see that.
Yep, so what they're doing with this test is they're measuring fit and finish for the vehicle. So there's a series of cameras that actually take into account all of the margins between hood and fender, door to fender, all of those gaps, puts up a measurement. The operators here set that and then verify that it's in place to our customer specs.
Wow, so you're actually doing body panel fitment on every vehicle to make sure everything's in spec.
Yes.
That's really cool.
So we're going to kind of get out of the norm. We're going to jump in this vehicle.
Oh, cool. Awesome. I'm going to jump in the back if that's all right.
Yeah, absolutely. So, again, normally you don't ride, just watch the conveyor. It is.
Yep,
So,
it's moving. Sounds great. Thank you. Jumping in this thing. First person. Yeah.
Yep. I will come around to the other side. So this is, again, paint inspection and finished visual inspection. So their operators are looking at stuff under the hood, verifying that all the other panels that go over some of the accessories and access panels for battery fluids, they're all in place and secure. They'll close the hood and then it will continue down with a visual inspection. Then completed the inspection with no issues. So we have a digital record of that as well.
Yeah, so every car gets logged. Any, I guess, blemish or something gets logged. And if you start to see a pattern, how do you typically address that? Do you just go try to find the source, or is there a process for that?
It's a complicated process, but yes, we would use the VIN information to find the front door or the beginning of the issue, and then narrow the population down so we inspect it and capture everything that may potentially have that issue.
Got it. Cool.
But exactly what Kayla mentioned, this is just the end of line process. Throughout our entire process, our philosophy is no fault forward. So where we can correct it in the station, we do. If we can't, then we'll have a side process where we'll make the adjustment and correction. But our goal is, like I said, no fault forward. So that by the time it reaches this point in the process, it should be a good vehicle with no issues.
Very cool. Yeah, and we got our guy over here. He just pulled some, packing material off the side of this, or some protection plastic. We're getting a little polish over here.
Yeah. Yes.
Nice.
So the plastic he pulled off, throughout the assembly process, there are what we would consider high contact or high touch surfaces. So we put protective coatings over those so that as we're building the vehicle, areas where operators and other parts may contact it, they're already protected so we don't have any issues.
Yep, makes sense.
You just felt they opened the tailgate to verify function of tailgate.
Oh yeah, cool. Check that out. That's awesome. So water test. What can you tell us about this here? Because you're just ripping water, and how do we know if it passes or not?
So once we come out of the end of the booth, the operators will open the doors and verify inspection. What we are doing is subjecting the vehicle to a pressurized water test that simulates hopefully the worst storm or conditions the vehicle will ever see. You'll notice nozzles on the top as well as underneath. And like I said, we're subjecting the vehicle to as much water that it could possibly see short of submersion to verify that all the seals, the door, and everything else, there's no leaks at all. And it's to the point where you literally can't see ahead of you. There's so much water.
Super cool. Yeah, this is like Tom's place in Florida right here.
I hope no one ever drives through this.
He's been letting just a few days ago.
Oh no.
Wow. Super cool. So how long does this test go for? About a couple minutes or so?
That's about 2.5 minutes. Yes.
Okay. Yeah. So we're just going to get blasted
Yes.
for 2 minutes. That's hilarious. Okay. Very cool. And I'm helping with the quality checks at the moment. No water ingress.
Correct.
That's a good one, Tom.
Giving it one last check for any obvious gross blemishes, say on the screen or the steering wheel or things like that.
So now we're getting all the water blown off. I would imagine this truck passed because we are not floating away at the moment. It's nice and dry in here, which is great. And we were just talking in the car earlier. These
folks that work here at End of Line, they're going to be pretty surprised to see us. Nick, do you think they're expecting us in here?
No.
It's going to be really funny. Be like, what's up? We're in here.
And then a driver gets in to drive it off the end of the line. Like I said, they may be a bit surprised when they open the door.
She's like, what are we doing here?
I'll do it.
Okay, you're doing the best you can.
Sweet.
Doing some seal checks.
The devices they have in their hand, that's another part of our digital factory. They are actual scanners. They can use that to scan bins, log information specific to the truck, and it's all portable and digital. It's used actually.
Yeah.
So the code on the side of the vehicle, that barcode is what they're using to scan.
Oh, okay. They're just saying that this truck reached this process, basically.
Yes. Yep.
So instead of going through the door, just make a left. And then very unique. They are completely silent when they start.
Yeah.
Perfect.
All right.
Cool.
All right.
Nice. Thanks so much.
Appreciate it. Thank
No
you.
problem.
Thank you,
Yeah.
sir. Appreciate
Thank
it.
you guys. Nice meeting you all.
Yeah, nice to meet you, Nick.
All right.
Appreciate it. So we're heading into sort of after end-of-line quality checks, doing a rough road check. And there's a series of surfaces that every truck gets driven over. And this is the process how that works. So this is underbody suspension frame mounts. Okay, just some cobblestone. Nice. This is looking for like interior trim rattles, I guess. And then underbody frame suspension mounts is the next one. And as the driver, what exactly are you looking for to see?
You actually looking, listening. A lot of listening, like anything that's unfamiliar.
So I shouldn't
like
say
it's
anything.
Loose or, yeah.
So now we're flexing it all out here. Nice. Off-road. Picking up the pace. Nice.
Any loose bolts, anything that might fall out. So you do it a lot of times. You'll catch different things.
And how'd this one do? Did this one pass?
Yeah, it sound like it. I ain't hearing it.
Yeah, I didn't hear anything either.
It's pretty quiet.
Yeah.
So we just came out of rough road and brought this thing over to the charging station, which they charge them up to 80% here at the DC hub. And then I guess that's probably all they really need to do, but they can go up to 100 for a final check somewhere else. But pretty sick. We're going to go take a look at their charging spot here. They even have heaters up there. Is that what those are?
Mm-hmm.
Are those heaters up there?
Yes.
Oh, neat. What do you need the heating for?
For personnel comfort and
Okay.
keep the hoses from getting extremely stiff and hard to maneuver in cold weather.
Yeah, good point. Good point. So guys, we're just out here. I figured let's go take a look at some of the charging stations from what we can see. So we've got some switch gear and what appears to be power electronics chargers all around. Some of them, I mean, they're all pretty much the same here. So let's see what we got going on. We've got CCS on either side. I guess they just start when you plug them in, but all of these power electronics units, I'm not exactly sure the power on these things. Probably 120 kilowatts, or let's take a look up here. It might show us. Let's see, we've got 270 amp input, 210 kilowatt output chargers. So they're big boy chargers. That's awesome. And these cables, no cable management on some. No, they all have kind of cable management, but they're super long cables. So you can really reach around. And this is where they get them charged up to about 80 or 90% plus or minus before they go off for shipping. That feels a bit high in my impression. I probably would have preferred to see, like 30, 40% for battery longevity, but they've got their process and they say it's totally fine. And they just juice them up so that they never have power issues during transport whatsoever. But
a ton of bays here. I can count how many there are, but yeah, it's got to be like 30 or 40 stations, something like that. It's one of the biggest charging parks I've ever seen. And it's right here at the F-150 Lightning factory. Super cool facility to just be able to pull out of the factory, do the rough road, and then juice up before transport. Tom, would you like to charge your Lightning at this station?
Yes, I want the actual official 40 electrons.
Yeah, actually, I guess your truck was charged here.
True, yeah.
So, but you didn't get to plug it in.
Yeah, and I picked it up at like, I want to say 60, 70-ish state of charge. So yeah, it's probably running off of these electrons here.
Yeah, probably so, I would imagine. That's super cool. And I mean, do we know how many bays there are? I think I'm counting somewhere around 40 or 50.
Yeah, that's a cool little offset.
Yeah, it's a pretty neat situation. And here comes one coming in for a charge. Sick. That's awesome. So anyway, that is, well, we love charging on this channel. And this is one hell of a charging station. All right, so we're doing a little bit of snooping. I wanted to see the substation power in this thing. So we're coming back over here and holy transformers, my goodness. And so this feeds the entire charging park. All of that to charge up some battery vehicles. You know, that's pretty cool. So love that they invested in all the infrastructure to be able to charge it up. Might be overkill in my opinion, but I think it's cool. Love to see all the DC charging just lined up. Well, guys, that was an absolutely awesome day with Rob and all of his colleagues here at the Rouge EV Center. I thought it was so cool that you were able to show us, you know, not only the water intrusion, but how a Lightning goes from basically painted body in white to final production. And my favorite part was getting to go on the rough road and see all the charging, because I've always seen photos. I'm like, I got to check that out. So thank you for making it all happen.
Oh, it was our pleasure. A little biased, but I'm very, very confident this is the best assembly plant in the world.
I love to hear it. That's amazing. Can't wait to see what the viewers think. This is such a cool opportunity. And yeah, you were so open and transparent, and so were your colleagues. And we can't thank you enough for that.
Our pleasure. Our pleasure. Come back anytime.
Thanks again, Rob. And thank you guys for watching. We'll see you in another one again soon. Bye-bye.